Yeah, hi everyone. So total 5 experiments we have completed. We have come to a sixth one. The convolution between two signals and sequences is our sixth experiment. So first I will be writing a program. I will be showing the output for a convolution between two signals. And second will be convolution between two sequences. In two separate files, we are going to do the programming. Okay. So in detail, sequence programming will be there in your digital signal processing subject. So already here, you have studied what is meant by convolution, right? Mainly in the analysis of systems, we will be using this. So here, if x of t is input and h of t is the impulse response, then output is always convolution between its input and impulse response. This is a very well-known factor. Okay. And now if this star symbol is used for convolution, right? Then the corresponding mathematical expression is this: x of tau into h of t minus tau d tau. Instead of tau variable, here I have used dummy variable as capital T. Lambda also we can use, whatever may be the dummy variable. Okay. Suppose whatever input signals I am taking, if all those are causal signals, means limits will be from 0 to t I have to take, because suppose if u of t is there, u of t will be defining only for positive values, right? U of t is there means 0 to infinite I have to write. U of t minus capital T. If u of t is included in inside h function, means u of t minus t. U of t minus t will be existing only for 0 to t. So this formula we are going to implement in our programming. But actually in our signal processing toolbox, there is an inbuilt keyword like conv. No need to develop the code separately using this formula. We can use this inbuilt keyword convolution of whatever inputs you give, that convolution will be performed simply by using this keyword. So only for sequences I am going to use this keyword conv, whereas for signals we are going to implement this formula. How means? I am going to give first input signal, I am going to give second input signal. After that I am going to multiply these two. After multiplying the two functions, I am going to use this keyword which is available, integration. Just for implementation of integration only for this expression I am using this. Integration of what? Suppose if this product itself, if I represent using some other variable, means z. If this product z, with respect to what we are doing integration t over what the range limits 0 to t. So 0 comma t, like this I am going to write. So what I am going to do, I am going to give first input, second input. After that I am going to multiply those two depending on my required expressions in the formula, like t minus tau. After that I am going to multiply those two. After multiplication, this product term I will be including inside integration. Int of this product z with respect to t over range 0 to t. Okay. So this is the logic behind the programming part. So you have to do the theoretical calculations for the input whatever I am taking. So as I already said, what is the input I am going to take? I am going to take my first input as exp of minus at into u of t. Okay. This is my first input I am taking. And my second input, that is h of t, I am going to take it as t into u of t. This is my second. For these two inputs, you have to do the theoretical calculations. Whatever expression I am getting for after implementation of this integration, the same expression you have to do using theoretical also. Okay. So this is our theory related to convolution. Now let us go for programming. Yeah, here is a programming. So anyhow, these three instructions are common. And what are the variables I'm using in the implementation of that integration? Time variable and dummy variable t. After that, one constant a I'm declaring it as 0.25. Next, I'm using command disp, disp, first input signal. Just it is showing inside disp whatever you read, that will appear in the command window. That's it. Okay. First input signal is also you can write whatever. Whatever you write, it will appear. Next, it's like printf. Input means like printf in your C language. X equal to input, enter first input. Disp is like printf, input is like scanf, reading the input from keyboard. Okay, reading input. This is for taking input or reading input from keyboard. Okay, input from keyboard. Enter first input. First input is exponential, e power minus 80. I said na, that one. Figure. I am creating a figure window. Two inputs I would like to plot in a same figure window. So two rows I have created, one column, first position. EZ plot I am using because variable is there. Variables I have declared, not exactly some certain limit is not there. So randomly it will be taking values on t x-axis and y-axis. What is the variable I am taking? X, whatever input we have entered. X label same time in second, y label amplitude, title first signal. Okay, this is about first input. H equal to input second signal input. Here what you have to give our input? T into u of t is my input. Okay, even if u of t also you don't give, here I am including limits only from t, means by default it will be included. Okay, h equal to input t we have to give. Subplot 2 comma 1 comma 2 ez plot, again random plot on x-axis, right? So ez plot of h, title second signal. So as I already said, we need to take the product, right? X of tau into h of t minus tau. So that is the reason t minus t I have written, x input as it is I have written, x equal to. Okay, now integration of y with respect to capital T comma over the limits 0 comma t. Okay, e power minus at is my first input, but I am taking product of directly x into, right? So e power minus a tau I will be giving the input, or a into capital T I will be giving the input, y comma capital T 0 comma t. Over the range or limits for the integration is from 0 to t. I am integrating the function y with respect to capital T. Again, ez plot of C, random plot. Title is convolved signal. So taking the first input, taking the second input, implementation of integration function. These are the three steps involved here. This is about the program. Now let us go for output. Let us see the output. I'm saving it and I'm clicking on run. So once you click on run, command window will appear. In the command window, it will be like give input, enter first input. Okay, here I see how I am giving input. Click on it, exp of minus a into t we have to give, but directly I am multiplying after replacing with dummy variables. E power minus a tau I am giving, but theoretical calculations you do for e power minus at into u of t, t into u of t. Okay, enter, x equal to, so first signal, enter second signal input. It is asking for second signal input. T minus t we have written, so t only you give, small t. T I have given. Okay, see here, I got the expression for convolved signal 4t plus 16 into exponential of minus t by 4, nothing but minus 0.25 t minus 16. This you have to get after doing the theoretical calculations. After doing the theoretical calculation for convolution between e power minus at into u of t and t into u of t. E power minus at into u of t and t into u of t convolution expression, convolved output is this one. This is a theoretical verification. Ez plot we have written now. So let us see the outputs also for this x, for this y, and for this c. So these are the expression. How the plot will be, let us see the plots. Okay, this expression you have to note down, see, and do the theoretical calculation. Same expression you have to get using theoretical calculations also. Okay. So here if you see the output, so this is my convolved signal output t. That means when t equal to 0, t equal to 0 means will be eliminated, and t equal to 0 minus 16 into e power minus 0. Some point 0 will be there. 16 minus 6 is 0. At t equal to 0, amplitude is also 0. So t equal to some expression, whatever c equal to expression we got. So at t equal to minus 6, if you substitute whatever amplitude is there, that will be plotted here. At t equal to minus 4, at t equal to minus 2, that is a plot here. Similarly, input signals are also going to be plotted. Okay. So this is about convolution between two signals. Now next we will be discussing about convolution between two sequences. Okay. Thank you.